the topic for today, from my perspective, is the AI, artificial intelligence, some technical rudiments of the artificial intelligence, and I just want to point out the question, is the artificial intelligence intelligent as it speaks, right? Okay, one slide about me, and as you can see, I'm a PhD in philosophy of science. I work in the Higher Baptist Theological Seminary, teaching their philosophy, logics, and ethics. I'm also MSc in programming, IT, and MA in cognitive science, and some also other stuff I have studied. But those are the three most important. I work on my daily basis at the industry as an IT professional, work in the cloud area, great installations of servers for big customers, and also on site the lectures for God's glory, for teaching young leaders, equipping them with philosophical tools, logics, and some ethical attitude, of course. Okay, the agenda for today, just to be sure on which stage we are. There is also the Q&A section at the end of the presentation, so please write down questions if you got some, and at the end of the presentations, feel free to ask them. I will try to repeat the question and answer as more strict as I can. Yeah, so let's begin simply. Computer evolution. The evolution word is used here by purpose, because on this network we simply at least don't like evolution as a word. And in here we can see some evolution, right? The steps, the stages from the computer developing, the software, or also the hardware developing, changes there. I will explain it on the simple graph. The first, it is the funny graph rather, not the historical truth. It is the complexity and the computation power available in the computers right here, right now. When we start in the 1900 or 1920, 1940, 1960, and so on, we just got computers really low powerful from our current perspective. But for that time, those computers, in those areas, were really powerful. People thought that that's the, let's say, future, right? It's unbelievable how fast it works. And from our perspective, they are on the bottom. Our current smartphones can do more than those room-sized computers, right? When the academic came to this room-sized computer, put the card in it, wait 8, 10, 12 hours for results of the computation, and then he was extremely happy that it was calculated outside of him. He don't need to calculate by himself. The computer did this. So it is intelligent, right? Okay, and now we can see that our computers can do more. And the computers are much more powerful. The evolution, let's say evolution with quotation, shows on the levels on bacterium, worm, lizard, mouse, and so on, right? But it is only the approach, let's say the comic presentation, how it will change. The curve is really going high. Moving then. So, the main part of computer is CPU, Central Processing Unit. And the CPU, the performance of this unit since the beginning, but that's not the beginning, 95 is not the beginning, but let's say from that time, till 2011, and now we just got 2019, the curve is really high. The performance doubled, tripled, fourth, right? We just got still more and more power available, the computation power for our usage as end users, because we, as end users of computers, we don't care how it will behave on the bottom level, right? We care about the usage. And the power is there. We can use it. And of course, the second graph shows the complexity of the processors and shows how much cores, how much threads are put there in this single unit. Of course, there are computers, there are server installations, the big ones, which got several processors with several cores, with several threads. They are multiplying each other. So we just got more and more and more power for our usage. And the AI. How AI is using this power. I will explain the intelligence and the AI rudiments later, but in here only, I want to show the milestones. We could, of course, change some of those. They are not the most important ever, but there is some representation of the milestones of history of AI, in history of AI. Of course, when we just got the first bullet, it is Alan Turing test. It's the absolutely fundamental thing which came to people's mind that the computer is thinking, right? Then changes. Of course, AI uses in the game industry, which is the most famous. That's the sixth, I believe. IBM Deep Blue beating the Garry Kasparov in the chess, right? Chess game. This is the 1997. Then some representations of AI, artificial intelligence, let's say the artist vision, how it will be in the future with AI, and some bright visions, and also some scary visions, like the machines will take the control and people will be, trapped by the machines and so on. That's the vision only. And now we just got recognizing, that's 9 and 10, recognizing the voice and also the vision. The vision is not there, but the voice, that's 9 and 10, the Google and Amazon, but also more. We just got, on iPhones, we just got Siri, on also other cloud vendors, we got other technologies. But that's the direction, right? Not only the computation for usage, for the normal user, then beating human, so it looks like intelligent because the program is predicting our movements in the chess game, in that case, and also recognizing our voice, our commands. Do this or do that. Launch email. Search me the best restaurants in this area, right? We don't need to write it down and search it. We just need to say it, or even maybe think it. But that's the future. As I said, AI is getting more and more popular. This is the photo which I have taken in Krakow, where I was living a few months ago. And this poster is saying double power of AI. It's in Polish, but so if you don't understand Polish, I will translate double power of AI. It's used by Huawei corporations for the Mate 20 Pro smartphone. So how smartphone, this which we simply use day by day, right? Every time, every one of us got the smartphone. I suppose. Everyone, right? Not everyone. Oh, so you're on the safe side. Yeah. Okay. So, double power of AI. It's from the 2018 time picture, Krakow, the big part of the city, the main part of the city. It's really big poster. The AI is present now in our society, in our devices, which we can buy. This poster says it. The AI is right here, right there. You can use it. But is it? The intelligence definition. As a philosopher and also as a scientist, we need to know that the definition is the first step. We need to define the thing to which we refer. I just found the definition in Merriam-Webster dictionary. It shows that intelligence is the ability to learn and understand, or at least deal with, new or trying situations. So in that case, intelligence will be ability to use elements in the set. We just got a set of elements, we can use it. So we can use the cup of tea to drink, to have a tea in it and drink the tea. Or we can use the cup of tea to, I don't know, to throw it or to play like a football in it, right? That is not the perfect usage, right? So rather, is the proper usage of the teacup is to drink a tea, right? Everyone agree, I suppose. So the usage of elements which we got available. But this definition is not sufficient, in my opinion, because some of those definition elements are fitted by the current, let's say, AI, right? But I will extend this definition to not only use elements properly from the set, but also extend the algorithm of usage those elements. So being more creative and, let's say, outside of the box, right? AI ecosystem, what's that? In general, that what we are thinking about the AI is not the one service. It's the service in some ecosystem. So among other services, which are complex, which are combined to each other, which are cooperating somehow, right? So artificial intelligence. I assume that most of us, if we will just get a survey, what artificial intelligence is and what is the great example from your perspective, most of us will point out one of those elements, at least. Face recognition, voice recognition, patterns recognition, deep learning, machine learning, neural networks, chatbots, right? And if I may ask you a question, what do you think? Is it available now for us? Have you cooperated with, let's say, now in quotation, artificial intelligence, or some elements of those artificial intelligence? Do you have or not? Do you have some experience in it? In the chatbots, let's say? Let me find you a situation. I will describe it. When you just came to the insurance company on the website, right? You just want to buy the insurance for your car. Normally, in the traditional way, there will be some customer service, let's say Tom, and Tom will provide you the best, or sometimes not the best, but let's say it, insurance opportunity for your car. That's what you need, right? And in that traditional way, we are totally sure that this service is intelligent because it's human-made, right? And currently, not in every, of course, service, but there are some services that when you came to the insurance website and you just want to buy the insurance for your car, there will some chat pop-up came out. Hey, my name is Tom, or something. How can I help you? And we just write down, I want to buy the insurance for my car. And he asked a couple of questions. What is the car from, what's the age of the car? What is the, I don't know, maybe, what's the size of the car and whatever, right? Some questions. You are answering those questions. And Tom, or this bot, is providing you some opportunities, A, B, and C. And you are choosing, from my perspective, the best is, let's say, B, because it's maybe not the cheapest, but the conditions are better than in the A opportunity. So I will choose the B opportunity. And that's it. And sometimes you can be maybe not sure, but you rather can predict that you were served by the human being, but not. It was the chatbot. It was the algorithm. He got some answer. He got some questions predefined, which need to be answered, and depending on your answer, it can skip some question because you answered before, or if it's, let's say, not so if it's not so intelligent, it will simply state the question and the second question, even if you answer it before in the previous answer. But nevertheless, it's the chatbot. That's not the human being. That's the part of AI ecosystem. Let's move forward. Relations. Relations, I really wanted to explain the common misunderstanding. Because people, when we just use the previous photo of Huawei phone, right, the smartphone, with double power of AI, it's rather not the AI, but it's something not so extensive. It's machine learning. And machine learning, ML, is not the same as AI. Why? Because it is a subset. AI definition is much more wider. We can also say that now it's really hard to define what AI exactly is. We know some elements. We know machine learning, we know NLP, natural language processing. We know recognition of voice, of vision. We know some other elements. Those are elements of AI, but they are not, when you just simply add those elements, they are not the AI itself. AI is something much more. It's not really known right here, right now. So, machine learning, in very simple words, is searching for patterns based on given criteria, which developer, of course, predefine, and it will go through the set of data, no matter what, if it's the data are structured or not. But we just got some bunch of data, elements, and through which we need to search some pattern. Let's say we just got pictures, 10,000 or million pictures. And on those pictures, there are lots of elements. But on 5 of them, from this million, there are dogs. And we just want to find out those million pictures and search dog pattern, right? We are searching dogs in these pictures. Normally, we should do this. See the picture, that's not a dog. Skip. See the picture, that's not a dog. See the picture third, oh, that's a dog. Put it here. See the picture 4, that's not a dog. And 10 years more, we just got 1 million, that's not a dog. finished, right? 10 years, not us. And machine learning helps us to do this subsequently, right? One by one. But we don't need to really take care how it will work. We just give them criteria. Search this. The dog looks like this. You just got a few examples here, right? If you got more examples of dogs, the more accurate the machine learning will be. But still, what one that I put emphasis on is that machine learning is the subset of AI. That's not AI itself, which is the very common mistake. And how does it works? So, few elements. Neural networks. I really wanted to be not very technical on this presentation because, as I suppose on the our network will be no rather IT guys, and I was true, because most of us there are medicine in let's say in field of medicine and some technical areas also, but rather not IT itself. So neural networks are simply used to find the solution combining the elements. When you just got a lot of elements, want to compare them, and find out, let's say, the shortest way out from the forest, right? We just got way 2, way 1, way 2, way 3, way 4, way 5, way n, right? And we just got some combinations, go this part of way A, this part of way 2, this part of way 3, blah, blah, blah. And then we just got the find out how to go out from the forest. And we can combine those elements and find out how to solve our problem. You can use the neural networks there. It's based on probability, so that's not 100% sure. And it could learn. It is in single quotations because it could also, in single quotations, invent something outside from available pattern. It means that if we got some elements, and even if developer think that we can combine 1 with 2, 2 with 3, 4 with 5, and so on, but he don't think that we can combine 6 with 11. Let's say, you don't predict, he missed this, simply. The neural network could, of course, do this, but let's say it, that's not something new. That is the new connection of existing elements. That's not something outside of the pattern, outside of the algorithm developed by the developer. Yeah. Going down. Some examples. On some of the videos will be the audio, but in this and the next one there will be no audio. So don't try to hear something because there will be no sound. Will be only the vision. We just got OCR example. I suppose that you know what OCR is. It's detecting the handwriting or even other characters, what it is. We just write 2, and it detects that's 2, right? So it works good. We just got 3, and detects that's 3. Simple and easy. And we just got 4. Oh, he missed. That's not good. Let's try that again. Oh, 4 and 7. Still not good. And we just got 4. Loud and clear. No, still not good. And we just skip this. We got 5. No, that's not 5, that's 6. And we just got 6. And it's perfectly fine again. But the algorithm, based on our set of data, can, let's say, learn how many elements. Okay, I will click this. Let's do this. Oh, skip this one. Okay, I will speak about this in a minute. Speaking about the OCR, finishing the thought, is that normally when we just got the handwriting is unique. Every person got different handwriting. And the OCR needs to recognize with the probability again what letter is which, right? So it is quite accurate, I should say, but it's still not intelligent. Again, going back to the main question, the topic. Is it intelligent? I suppose that none of us agree that the OCR, recognizing characters, recognizing elements, it's not intelligent because it is based only on the pattern. So it's not the AI, it's rather machine learning. Much more interesting is the deep learning example, because the neural network and the OCR was very basic level. Here, we just got the race of these cars, if we can say that there are cars, those red blocks, there are cars, and if any of this car hit those crosses, it will crash, let's say, and you need to go start from the beginning. But deep learning assumes that if the car is hitting some cross, on the next try, he will miss this cross. And how he will miss? He will change the pattern of this car. The car will drive in a different way. The beginning will be the same, but when this car will be close to the cross, he will try to miss it. If the cross will be bigger, we need some more tries to get bigger angle, right? To miss the cross. The third thing about the AI is the optimization. What it is? In short, it is the way to more accurate fit to the conditions which we have, right? From the customer and from the service perspective. When we have a service, when we just got an application, when we provide some service for the customer gives us the conditions, and he wants this, this, and this, and we need to fit those conditions. How to do this? Normally, when we just provide the first stage of the first version of the application, we are almost pretty sure that it fits. But when a customer sees this application, he says, that's not it. It is close, but I will change this and this and this. So we need to, based on those criteria, fit our algorithm or fit our application. This means that we just got 3 steps. Initialization, selection, meaning the fitting to the customer or client expectations, and then termination, meaning end of service, right? End of life of the service. So we just got initial conditions, then we try to here changing constantly conditions and implement those elements to our program. And not to treat, that's the funny word, very popular in the technical area, not to treat the machines or algorithms as pets, which we love, right? But rather as a kettle, which we use. And those machines are not living, they are not our friends, they are simply machines to use. That's the totally changing direction. Again, we try to fit the customer expectations and terminate without harm elements. And what does it mean from the AI? That AI algorithms the applications are constantly changing, and they are trying to fit, trying to learn our expectations. The previous example of this driving cars was quite nice, because the car was fitting the expectation, right? He was driving like this, and then he hit the cross. It's not good to miss it. So the next stage, next try, miss the cross, and again, and again, and again. Just try to fit and perfectly be up to date to the customer or conditions, right? Expectations, and solve our issue or complete our task. In that sense, finish the race, right? In the car example. Or in other example, just to be much more accurate for the customer expectation service. The optimization example is quite common, I suppose. As I mentioned, that most of us got smartphones. And most of the smartphones, even if they are not smartphones but normal phones, they just got the camera. Who got camera in his, her smartphone or phone? Everyone, yay. So, normally, when the very initial stage when cameras came into the phone or smartphone, they were very primitive. They can take a picture, they got no predefined scenarios, categories. They just took what they are in the vision, what is in front of the camera. Simply take a picture, nothing more, nothing less. But now it's not sufficient. For most of us, if we like photography and from the smartphone photography, we expect that it will, let's say, recognize the scenario. We just want that the camera will fit the hardware, fit the software possibilities, software setup, to be accurate with the scenario. So if we get the portrait photo, let's say selfie, we want to, that camera will focus on our face, but something which is behind us could be even blurred, just to get the better contrast, right? Because our face is the most important there, not the something outside of us, right? And for the other categories, we just got also the similar mechanism. We can more accurate the settings of camera when we just got the macro or the close distance photos, when we just got text, when we just got night portrait, when we just got in the really shining sun, when we just got the cloudy sun, when we got, I don't know, sunshine, snow, reflections, any others. The camera should fit our expectations. It should recognize, should detect what we want to take a picture. And that's, again, machine learning, not AI, which was on the poster, right? Double size of AI or double dose of AI. Okay, moving next. Cloud solutions. Are you familiar with cloud perspective? What is it? The cloud, meaning the servers, not the cloud as a weather on this area. So cloud, in that sense, is nothing more, nothing less than the big server installations, which are provided for us as end customers in exchange of money or some other benefits, or data, our data, personality, and whatever. And of course, normally, in the traditional way, when we want to analyze the data in the, let's say, past, we need to provide the data in a certain way that computer can read it and can transform it. That could not be any data. In traditional way, it will be not acceptable by the program to provide the handwriting note, the photo, some movie, document, and let's say the table from Excel. He don't handle it. But that's the past. Cloud solutions help us in some services, like in that sense, as somehow advertisement, but maybe not, Azure Data Lake, which provides the unstructured data. It's totally new paradigm for us. For human beings, that's normal, I suppose. That if we just got the topic, let's say dogs again, right? And we just got 5 pictures of dogs, and some movie about dogs, and some sound of dog's life, and some text about dogs, and some, I don't know, dog's toy, right? We just got all those data, which are totally different data, in different format. We recognize that the main part of this data are dogs. That's totally obvious. But from machine, that are data which don't show nothing. That are very different data in different format. If you want to distinct what is the main plot, main topic of this data, you need to provide data in a specific way. Let's say the program is available to transfer text. When we provide the text in English, text in German, text in French about dogs, it will handle that the text is about dogs, and it's cool. But still, different formats, not acceptable. Now, it is acceptable. It is also acceptable not only in the format side, so we can provide to the data lake storage photos, documents, movies, sound, I don't know, handwriting. It will detect the plot. Of course, with the probability, it's not 100% accurate, but still, it is a totally new paradigm for us. What is, of course, quite normal for people, human beings. And the face recognition, second Azure feature, which seems to be intelligent. And I provided the application which uses the Azure Cognitive Services API to detect face. I was quite worried if it will be good approach to precompile it in here and show it. So I prepared some slides from this application working on the real example. Of course, myself, again, because I write this program. And just to show the small background, it will notify the gender, emotion, hair, glasses, some special elements of the face, right? So if we show to this application some picture of, I don't know, town hall, it will not detect the face because there is no face in it. But if we show the picture of human being, it will detect the face and show some metadata about this predictions about this person. I will comment, of course, later. And also it will approximate the confidence level if this person, which are on the picture, is the same person of the another picture. And why it works like that? Because it was one of the projects which in which I was involved to detect if we got some database with pictures of employees of the company, and some guy or some girl is coming in front of the door. There is a camera, and the camera will take, let's say, a picture or streaming the face, and it will combine with the data from the database. Oh, that's our employee. Let's open the door seamlessly, without any keys, key cards, whatever. But if there is a person outside of the company, so that's not a worker, right? It will notify that the confidentiality level is not good enough, let's say 20%, that this could be a person X, but 20% is not enough. Let's say 60–70% will be okay. If the criteria will be fit, then open the door. If not, then don't open the door. Seems to be intelligent, right? Like people, recognizing ourselves. That's me, as you can see. Again, so that's me as algorithm shows. That's the female. Face male. I'm sorry. That's the male. Male, 32 years old. That's not good because I've got now 32 and then I got 31. So it's not good. But still, male, 32, smile 0%, emotions natural, almost certain that it's natural. Isn't right? Natural, at least. Some colors of the hair. Okay, other colors. Then the mix of colors is maybe not so important. But still, there is a male person. For sure. It detects the face. That's good. Now, in the database, my picture and my picture in front of the camera. The algorithm detects from the verification result that these two faces belong to the same person. And this algorithm is confident in 80% that this picture belongs to the same person which are on the database. So we can simply open the door, right? Works smoothly. Very nice. But here the party comes. When we just got myself again, and some random photo from the internet, that's the Ice Cube, very happy guy with the butt, right? So we just got the verification result. Those two faces belong to the different person. Sounds good, right? But only in almost 5% sure. Is any one of us thinking that this is the same person? Anyone? You think, Alexander, okay. Okay, so this algorithm, of course, detects any other faces. It's nice element. And what is bothering us, the confidentiality level, 5% only. That's not much, I must say. And of course, we can cheat this algorithm again. It's not so good. And I suppose that every one of us will pass this test, but algorithm didn't. This one. We are unable to find out face. Oh. I suppose that most of us, or I'm almost sure that everyone will guess that this and this person is the same person, right? Or at least that's a person. Or I don't know what it is. It looks like FBI agent, I know, but still, we just, I assume that we are sure that that's the same person. Let's see that the background is even the same, right? Maybe the color of the shirt is different, right? But I don't know how to say it, the position of this person is the same. It's in the same place. So there is a big chance that in the same place there will not be a dog or, I don't know, alien or whatever, but the person, at least the person. But in that case, algorithms were unable to find the face in it. So they are, in this case, algorithm is not able to detect if this person is the same person on the picture, at least. And even I just got on my personal computer the same thing. When I just got the Windows Hello algorithm implemented on my personal computer at home, it detects me without logging, passing the password and simply face recognition. But if I simply take off my glasses, this normal reading glasses, not sunglasses, right? It will not detect me. He thinks, that seems to be a different person. That's not you. But that's still I am, right? If I take off glasses, you recognize me, right? Still, you know that I am who I am. And now, I am again, right? But in that case, algorithm will detect, oh, hi, Przemek, that's you. Let's get in. And without glasses, oh, I don't know you. So it's not accurate again. The most famous field of AI implementation on the greater scale is video games. There is some history. I will not explain it very widely. I will show some short videos, 2 videos from the video game. But small background is that AI in video games are used to be, how to say it, in the highest level, try to show to the player the human real behavior, the natural one. That's not the face recognition, that's not the pattern searching, but trying to show the human behavior in the real life. That we are pretty sure, or we at least pretend to think, that on the other side, our enemy or friend in the game is the real person. We feel, playing this game, that this person can be intelligent, can think. What does it mean? That's, of course, the body motion, that's the face motion, face moving elements, that's way of talking. Again, that's learning from the mistakes. If we are trying to shoot our enemy in the, let's say, first-person shooter game, on the second try, he will, let's say, crouch somewhere or not get in front of us to be shot, right? Just simply hide somewhere. And in that areas, it seems to be intelligent, seems to be useful for us and natural, right? Like the human being. I suppose it's pretty obvious in the light of the presentation and my speak today that AI that is not intelligent because programmer during the creation of the code need to decide what the algorithm will behave. He need to predict elements, the paths, how it will behave. He needs to be sure that program will behave properly. If there will be an exception, in that sense, program will behave not in the proper pattern, then it will glitch, it will suddenly exit or be closed, right? Then it will not work properly. Maybe some graphical artifacts will appear, whatever. Second is that neural networks can, let's say, by themselves learn. That's the situation that they can combine elements from existing set. Even the elements, even the combination which were not provided by the programmer initially. But, the big but based on provided data solution implementations. They are not autonomous, they are not outside of the box, they cannot be creative, so extend the algorithm. And today's AI heavily tested, implemented in many ways, and it can be approached in the different approaches. It can be implemented in different approaches and developed. This means, like on the poster in US regarding guns, not guns kill people, but people kill people. So in that sense, not AI is harmful for us, but people implementations of AI could be harmful for us. So that's not the AI fault or ML fault, but human implementation fault. So we rather need to provide more focus on ethics, which will Jeremy show us, right? Than the technical solution.